let's discuss about what is meant by ozonolysis. Dear all, ozonolysis. It's a very important reaction for the preparation of aldehydes and ketones from alkenes. Let's see the procedure in detail, and I will show you one of the short trick how to write the product directly. See, ozonolysis product or the reaction means we can split it into two reaction. There's two steps are there. First step, that is addition of ozone. You know, ozone means O3 molecule, right? Second step, that is called lysis. Lysis means breaking of bond. So breaking of certain bonds. These are the steps involved in ozonolysis process. So what is the purpose of ozonolysis? That's very simple. Ozonolysis is a chemical reaction which is used to convert alkenes, right? Alkenes into aldehydes, aldehydes and ketones. First, we can study the detailed mechanism of the reaction, then we can go for a short method how to write the answer directly. Okay. So the alkenes, when you treated with the first one to the alkene, you have to add ozone, and the second step we have to break certain bonds. Let's see the mechanism in detail. For example, let me take the simplest compound, simplest alkene, that is CH2 double bond CH2. You know, it is known as what? Ethene, right? Ethene. Two carbon contain a double bond containing compound. CH2 double bond CH2, that's called what? Ethene. To this ethene, I told you the first step in this reaction is the addition of ozone. You know, ozone means O3. What you have to do means, all of you please remove the double bond. First of all, CH2, you can see there is a double bond. First, you try to remove the double bond. Then remaining species, please write it. What is the remaining compound? CH2 and CH2. Alright. First, you remove the double bond from your alkene and just write the remaining species. Now, you can observe that there are 3 oxygen atoms, right? There are 3 oxygen atoms in one ozone molecule. You try to make a ring compound. Means 1 oxygen above and 2 oxygen below, like this. Always, okay? So, wherever you can observe the double bond, just remove the double bond and make 1 oxygen above and 2 oxygen below. Make a ring structure. Alright? So the first step over. I told you ozonolysis carry a 2-step process. The first step is the addition of ozone. That's over. Next step, breaking, lysis. What is the name? Ozonolysis. Ozono. First one, addition of ozone, and lysis. Lysis means breaking. How the breaking is happen? Breaking is happen in presence of one of the reagent called zinc along with the water. The breaking of this complex is happen in the presence of zinc and water. And where is the breaking happen, dear all of you? This and one more thing, what is the name of this ring compound is known as? Just keep in mind, the ring compound is known as ozonide. The alkene reacted with the ozone, the product is known as what? The ring compound is called what? Ozonide. Alright, ozonide. How the breaking is happen? Let's discuss detail. All of you, the breaking always done in such a manner, break this bond and this bond. This is the way of breaking. This is the way of breaking. When we are breaking in such a pattern, you can observe there is an oxygen above, right? There is an oxygen on the top. This oxygen goes with the zinc metal. The oxygen will react with it. This zinc can react with this oxygen and zinc oxide is eliminated. So let me write zinc oxide is eliminated from the system. That's a byproduct, right? What is our major product? Your major product is located the left and right side. What you have on the left side here all? CH2O. Let me rewrite. CH2O plus what do you have here? The right side, this is also CH2O. See all of you carefully. See all of you carefully here. CH2O, what is mean by? Here carbon already 2 bonds are with the hydrogen, right? Here carbon already bonded with the hydrogen. So 2 hydrogen already bonded. and this carbon oxygen bond should be a double bond. So what is that compound actually? HCHO. CH2O compound is nothing but HCHO. That is what? One carbon contain aldehyde. That is methanol. So HCHO, what it is called? Methanol. Methanol. Plus, what do you have right side? The same thing. HCHO. That is also methanol. Methanol. One carbon contain aldehyde. Dear all, when a alkene undergo ozonolysis, either your product will be aldehydes or ketone. Sometimes you will get both aldehyde and ketone. I will show you the example. So when ethene undergo ozonolysis, first we made the ring compound that is called ozonide, and ozonide breaking with the zinc and water, and we break in such a way the oxygen goes with zinc as zinc oxide, and left side you have CH2O, right side you have CH2O. CH2O is nothing but HCHO and CH2O HCHO. What is that? Methanol. Alright. Now I will show you what is the shortcut method. What is the shortcut method, or the simple way how to write the answer, the product directly. Very simple. Take your alkene once again. What is alkene? That is ethene. What all steps you are doing on this reagent, dear student? First step, you are adding ozone. Alright. Second step, you are adding zinc and water. Yes or no? First step, you are adding ozone. Second step, you are adding zinc and water. So I'm going to write the final product directly. So simple, dear all. Where you can observe the double bond, that you break it. The double bond, you break it. Make one oxygen left side, one oxygen right side. Finish. Break the double bond, one oxygen left, one oxygen right. What do you have left side? CH2O. What is CH2O? I can write it as HCHO. That is what? Methanol or formaldehyde. You know, methanol is also known as formaldehyde. What do you have right side? CH2O. That's also HCHO, methanol. Okay. So if you want to write the complete procedure as per the mechanism, first add ozone, remove the double bond, make the ring. One oxygen above, two oxygen below. The ring structure is called ozonide. Then treated with the zinc and water, breaking, product is ready. If you want to calculate the answer directly, the final answer directly, we have to just break the double bond, put one oxygen left, one oxygen right. That's it. Let's go for some more example. We'll get the idea detail. Second example. CH3CH double bond CH2. You know, this is the 3 carbon contain alkene called propene, right? Propene. What happens when propene treated with ozone or when it undergo ozonolysis? Let us see first of all the detailed mechanism. So propene is the alkene. When it is treated with ozone, O3, what happened? I told you. First, you remove the double bond. Alright, remove the double bond. Okay, only the double bond. Alright, only the double bond. So let me write CH3, CH, CH2. Alright, just remove the double bond. And place this oxygen atom. How we can place the oxygen, dear all? One oxygen above. Where you remove the double bond, on those carbon atom, you have to place the oxygens. Okay, so oxygen. Oxygen, oxygen, oxygen. Alright. What is the last step, dear all of you? Treat with zinc and water. The breaking will happen. How the breaking is happening? This bond and this bond. You don't worry about the upper oxygen. The upper oxygen goes with zinc as zinc oxide. What you have on the left side? The left side you have CH3, CHO. Left side you have CH3, CHO. Dear student, this carbon oxygen always will be double bond, right? Because CH3 single bond, C single bond hydrogen. The carbon already 2 valency satisfied here. So remaining 2 valency should be with oxygen. So this is CH3, CHO, or I can write CH3, CHO. This is the compound going to form. And what you have on the right side? Right side we have CH2O. We will write it as what? HCHO. You know, CH3CHO, this is a 2 carbon containing aldehyde. So what we can call ethanol, right? Ethanol, ethanol. And this is what? Only 1 carbon. Therefore, we can call methanol. Methanol. Shall we go with the shortcut method? How we can write the product directly? Dear all, take your alkene once again. What is our alkene? Propene is our alkene. Alright. What we are doing? Let us do in the single step. First, we are adding ozone. Second, we are treated with zinc and water. Breaking will happen. What we have to do? Remove or cut the double bond. Cut the double bond. One oxygen left, one oxygen right. Finish. What you have left side? CH3CHO. Easy or not? CH3CHO plus what you have right side? This is very careful, okay? CH2O is nothing but HCHO. HCHO. Okay, so this is ethanol, this is methanol. Clear all? So for your board examination, if they ask question related to the ozonolysis process, you have to follow through this mechanism. For a competitive examination, you can follow the shortcut method. Some more questions. Let us practice, dear all. Third question. CH3, CH, double bond, CH, single bond, CH3. What is the name of this compound? What is the IUPAC name of this compound? There are total 4 carbon atom and the double bond is on second position, right? We can call it as but2ene or 2-butene, all right? Okay, let us add ozone first of all. When you add ozone, what will happen, dear all? Remove the double bond. You will get CH3, CH, CH, CH3, all right? After that, make the ring. 1 oxygen above, 2 oxygen below. Now what is the next step? Treated with zinc and water. Break the bond, everyone, like this. If you break the bond, what is the product you are getting in the left part? CH3 CHO. CH3 CHO plus. What do you have right side? Same thing, right? CH3 CHO. Of course, it's correct one. What is the product name? Ethanol. Ethanol. Both are ethanol molecule. Shall we go with the short trick? Here we have CH3 CH double bond CH CH3. When you treated with ozone and we treated with zinc and water, what is the product? Dear all, in these cases, break the bond. 1 oxygen left, 1 oxygen right. Yes, product is ready. CH3CHO, CH3CHO. You will get 2 molecule of CH3CHO. Is it right? So we are preparing now. Now all the example what we discussed, we are getting only aldehydes. But I told you when alkene undergo ozonolysis, we will get aldehydes and ketone also. Let's see ketone. Fourth example. CH3, CH3, double bond, CH, single bond, CH3. Suppose this is the alkene, let me give you. Let it undergo ozonolysis. So first addition of ozone. So we want to remove the double bond, right? As per the procedure, as per the mechanism, remove the double bond. Let me write the compound CH3C, CH3, correct? CH3C, CH3. And right side we have CH, single bond, CH single bond CH3, all right? And you can observe we have to make the oxygen. So 1 oxygen above, 2 oxygen below. Done. Let us treat with zinc and water. Dear all, when you treated with the zinc and water, where we want to break? This and this. Correct? What do you have left side? CH3, okay? C, okay? This carbon having one more CH3, okay? I told you carbon oxygen bond is what? Double bond. So CH3, CO, CH3, CH3, CO, CH3. It's a ketone, right? Total there are 1, 2, 3 carbon atom. We will call it as what? Propan 2-on. Second position ketone, propan 2-on. What about the right one? CH3CHO. CH3CHO. What is CH3CHO? Ethanol, right? So you are getting both ketone and aldehyde. Clear all? So as per the shortcut method, we can go through that. CH3, CCH3, double bond CH, single bond CH3. What is the shortcut method, all of you? First treated with ozone, second treated with zinc and water. What will happen? Break the bond, one oxygen left, one oxygen right. What do you have left side? CH3, CO, CH3. CH3, CO, CH3 plus, what do you have right side? CH3, CHO. CH3, CHO. Clear? So simple to write the product when a alkene undergo ozonolysis. So ozonolysis is a preparation of, or it's a conversion of alkenes into aldehydes and ketone. It's having two steps. First, addition of ozone. Second step, the breaking of the bond. What is the ring structure is called? Ozonide. All the ring compound we will collectively call ozonide. Ozonide is splitted by zinc and water. This is the way of breaking. Alright, this is the way of breaking. The upper oxygen goes with zinc as zinc oxide, and left side, right side, what you have, that is your product. Now we can go for some more question. How to write the product directly, okay? First one. CH3 twice, C double bond, CH3, CH3. Suppose this is the compound I'm giving to you. When it undergo ozonolysis, what can be the product? Let's see. I'm just rewriting the structure once again. There is a carbon, right? On this carbon, two CH3 groups are there. So let me write like this, CH3, CH3, all right? And double bond, again one carbon, CH3, CH3. Yes or no? Expansion is clear? Now, let us treat it with, first with ozone, second we are treating with zinc and water. So how can we write the product, dear all? Direct method, okay, direct method. Break the bond, one oxygen left, one oxygen right. What we have on left side? We have CH3, carbon with oxygen, always double bond right here, CH3C, double bond oxygen, this carbon connected to one CH3 also. What is the name of the compound, all of you? Propanone. There are 3 carbon atom, second position there is a ketone. Propan 2 on. Plus, I hope the same product you will get it on the right side, CH3, CO, CH3. CH3, CO, CH3. Both are same product. Keep in mind, all of you, we said the compound is known as propan 2-on, or you can simply propanone. It's also known as acetone. Acetone. Propan 2-on is also known as what? Acetone. Okay, so both are acetone or propan 2-on. Clear? One another question. Suppose this is the alkene giving to you. You can see this is a cyclopentane with an alkene carbon 2-methyl group. When it undergo ozonolysis, first with ozone, second with zinc and water, what can happen? Let's see, dear all. Break the double bond. Alright? One oxygen left, one oxygen right. All of you tell me the answer. What is the structure? This is a cyclopentane ring. Alright? This cyclopentane, this carbon connected to a oxygen through a double bond, right? Double bond. Yes, this is the compound. And right side, what you have? CH3, C, CH3, double bond O. This is our propanone, right? CH3, CO, CH3 is called what? Propanone. Propanone is also known as what? Acetone. What about this? Here, a cyclopentane ring with a ketone. Cyclopentanone is known as what? Cyclopentanone. Cyclopentanone. So whatever the aldehydes or whatever the alkenes they are giving to you, you can prepare the aldehydes and ketone such a way. Alright. Now the another type of question, they will ask you the reverse question. What is the reverse question? They will give you the products. What are the products during ozonolysis of an alkene, aldehydes or ketone? They will give you the products. You have to write the reactant. Means they will give you the aldehyde and the ketone which is formed in the reaction. They want to know from which alkene you prepared that. That's also a method is there. Let's see. So one of the question is this one. I'm giving you two two reactants I'm giving. Definitely we'll get two reactants during one ozonolysis of alkene, right? So I'm giving you the product is, one is CH3COCH3. What is this? Propanol. The other one is CH3CHO, ethanol. So your products I am already giving you, one is propanol, one is ethanol. If you want to get these two products, what is the alkene we have to consider? That's a question. So dear student, we can easily prepare, follow this method. Take your compound, first compound, you just draw in another way, that's it. First compound, let me draw CH3COCH3. What I did? Dear student, please, CO group will be there. If it is an aldehyde or ketone, they contain CO group, that is called carbonyl group. Even these compounds, right? How can I write this compound in another way? CH3CHO. CHO bond, we can write it as COH, C double bond OH. Aldehyde and ketone contain CO group, that is called carbonyl group. That carbonyl group, the oxygen you please write below, like CH3CCH3 double bond O. The oxygen you write it below. Okay, this is the first compound. Hope you clear how to write the how we converted this propanol into this format. All right. Now we can make ethanol into this one. Ethanol into this form. Just writing reverse order. CH3C. The carbonyl group you write together and oxygen should be below. That's my purpose. So CH3C. One hydrogen is already there, right? CH3CH is there. This carbon connected to one oxygen. Just try to understand here all of you how we converted these two compounds into this formula. The CO group you write below and the other compound CO group you write below, and they should be adjacent. Clear? Now, next duty is that just remove this part, alright? Just remove this part and you make a double bond between the two carbon atom, which means here is a double bond. What I did, remove this OO part and make a double bond between these two carbon. Your product is ready, dear all. Your product is ready. This is your alkene. If you have a confusion, you can go with the same procedure. This is the alkene, right? You do ozonolysis. If you did ozonolysis, if you're getting these two products, then you can confirm it, right? So let us see what happened when it undergo ozonolysis. When it undergo ozonolysis, what you will do is here. You will break this double bond and one oxygen here, one oxygen here. Your products are ready, right? Products are ready, right? Let us go to one more question. Suppose I am giving you CH3COCH3 propanol with one more propanol. Okay, so both of the products are propanol. So from which alkene you can prepare these two ketones? Let's see. I told you the CO group on both of the compound, right? Together and oxygen make it below. Means CH3, C double bond O, CH3. This is the first compound. And second compound I can write CH3, C, CH3 double bond O. Clear how to write? Clear? Okay, so CH3, the C oxygen below, right? And also the CO group should be nearby. After that, what we did, dear all, we have to remove this oxygen part and make a double bond between those two carbon atom. Finished. Your product is ready. This is the alkene. Clear, everyone? I will give you two questions, the last two questions. Hope you can able to answer. When I am writing the question, just pause the video. Okay, after writing the question, just pause the video. You try to find your own answer, then you check with the solution. So this is the two questions. First of all, what is this compound? Propanol. 3 carbon contain aldehyde is called what? Propanol. The other one is, this is a ketone. Total 4 carbons are there. Second position there is a ketone. So this is called propanol. This is called butane. 2 on. So this is a ketone. This is an aldehyde. So dear all, how can we write? CH3, CH2, CHO, can I write it as CH3, CH2, CHO, right? CHO we can write like that, right? CHO. And here CO group already there, alright. What is our duty? Make this CO group on both of the compound together and oxygen below. Such a way we can write it. So first compound, let me write CH3, CH2, CHO. Alright? How can we present this one? Let me start from here, okay? CH3, CH2, this CH3, CH2, then C, double bond O, this one, and the C contain one CH3. That's it. Now what is the next duty? Remove the CO group, means the CO means oxygen atom, and make a double bond between those two one. Remove this part, all of you. Yes. Ready, right? Ready. This is the alkene which is going to form. Clear everyone how to write the alkene or how to prepare the alkene from which these products are formed. Okay, one last question. One last question for your reference. This is the ketone plus this is the aldehyde. How can we write? In this compound, we can write CH3, CH2, C, double bond O, right? The CO below, and the remaining group we can write on the top, CH2, CH3. And how we can write this CH3, CHO, dear all of you? CH3, CHO, right? We can write as CH3, CHO, correct. Hydrogen is there. Hydrogen, no need to write it as a branch on the carbon atom itself. You can write it CH. So remove this double bond O and make a double bond between them. Product is ready. So this is the alkene which is going to form. Okay, so hope you clear how the way to convert a alkene into aldehydes and ketone by using the process ozonolysis. So dear all, ozonolysis mainly we are using for the conversion of a alkene into aldehydes or ketone. Maybe your products are both are aldehyde or both are ketone. Sometime one aldehyde, one ketone. Anyway, you will get two products. How many steps are there in one ozonolysis process? Yes, two steps are there. What is the first step? Addition of ozone, make the ring compound that is called ozonide. What is the second step? The ring compound we will break in such a way by using zinc and water. Very good. Zinc and water, we will get these products. So this is the way how to write the detailed mechanism of the ozonolysis, or by using this technique you can write a shortcut method. So you can expect two different type of question for your entrance examination, competitive examination. Either they will give you a alkene, what are the products when it undergo ozonolysis, one type. Second one, they will give you a products, your aldehyde and ketone products they will give you, and from which alkene you can prepare this by this way. You can calculate it. Hope you clear the idea about ozonolysis. Thank you all. Bye.